All right, let's jump right in. Welcome to this explainer. Today, we are looking at something that is just completely fascinating. We're talking about a masterclass in how human beings process information, but it's cleverly disguised as a sixth grade science simulation. It's called The Dig, and it's a core part of the Patience framework developed by the Chalk and Ledger group. So, over the course of 10 days, students step into the role of junior archaeologists, and they're tasked with excavating a fictional location called Site 14. But here is the secret the students definitely do not know. The game is totally rigged. It is intentionally designed to trick them. It lays out this massive cognitive obstacle course, deliberately baiting the students into falling for their own psychological biases. It's an incredible look at exactly how our brains work, so let's get into it.
Think about it for a second. If you were a 12-year-old, or actually, let's be honest, an adult, and you were given a limited budget to dig up an ancient site, what are you going to go after? The flashy, exciting clues or the dull, everyday garbage of the past? Okay, let's dive into this, because this simple choice forms the entire psychological trap of the simulation. The students are handed a grid map, 3 visible surface clues, and a budget of $9,000, and every single square they dig costs $300. So right out of the gate, they are forced to make high-stakes decisions with totally incomplete information.
The simulation basically sets up 2 distinct paths, and it perfectly captures that tension we all feel between excitement and accuracy. The exciting path has students naturally clustering their limited budget around dramatic surface clues. Things like a stone foundation. They find metal, they find weapons, they feel like these great world-famous explorers. The methodical path, on the other hand, requires students to spread their digs out evenly across the whole grid. They have to ignore all that flashy stuff just to catalog mundane items like broken pottery and old fish bones. And here is the stark irony of the dig. The correct way to play this archaeological game, the path that actually gives you the true story, is to be as boring and methodical as possible. To really understand the trap here, we have to look at the actual physical stratigraphy of Site 14. In archaeology, time literally runs downward. The newest stuff is the shallowest, and the oldest stuff is the deepest. So the newest layer, which is just 150 years old, was this brief military outpost. Then the middle layer, 400 years old, was a massive farming village. And finally, the deepest, 800-year-old layer was the original river fishing camp. Do you see the trap here? The newest, shortest, and honestly least historically significant layer is packed with metal and weapons. It acts as shiny bait. Meanwhile, the oldest, deepest layer, which actually explains why humans ever settled this riverbank in the first place, is full of boring fish bones. And this setup leads us directly into our first major psychological trap, anchoring bias. By definition, anchoring is what happens when the very first piece of evidence you encounter becomes the lens through which you view literally everything else. Instead of letting the evidence slowly build a theory, your brain just builds a theory instantly and then forces all the new evidence to somehow fit inside it. So let's see how this actually plays out on day 1. The students look at their map, they see a surface feature, a stone foundation in square A4. Naturally, they immediately blow their initial budget right there. And boom, they hit the jackpot. They find metal nails, a glass bead, a buckle, a stone block. The trap snaps shut. The students instantly anchor on a highly confident hypothesis. This is a military fort. They lock onto this completely false narrative right out of the gates, and this single day 1 assumption is going to completely blind them to the real history of the site. Fast forward to day 4, and the simulation pushes back hard. In square C3, students dig up a weapon fragment in the shallow layer 1. But when they dig deeper into layer 2 of that exact same square, they find a cooking fire pit and grinding stones. Think about that. A weapon sitting directly on top of an ancient kitchen. Stratigraphy tells us the kitchen is hundreds of years older. But remember, the students are anchored. This specific contradiction forces a critical choice. Do you update your theory based on the deeper, older evidence? Or do you stubbornly explain the exception away, claiming something like, well, the soldiers must have just really liked grinding their own grain? Which leads us into our second major trap, availability bias. This is the phenomenon where dramatic, flashy evidence is far more memorable to our brains than mundane evidence, even when the mundane stuff is actually way more important. The loud evidence is simply more available to our memories. Now, what's really interesting about this is how completely those flashy artifacts can blind us to reality. Because on day 7, a major discovery hits. If the students finally decide to dig near the river, they hit layer 3. They find fish bones, simple stone tools, and fishing weights. The contrast here is just night and day. The metal weapons are shiny and super memorable, but they only represent a tiny 50-year blip in the site's history. The fish bones, on the other hand, are boring and totally mundane, but they represent the true origin of the entire settlement, from 800 years ago. Availability bias essentially tricks the students into heavily weighting the shiny weapons in their minds, blinding them to the reality that those boring fish bones are actually the most historically significant find on the entire grid. So as the students slowly figure out that they've been duped by their own brains, a new problem emerges: hindsight bias. This is that deeply human tendency to rewrite your own memory after you learn the correct answer, basically convincing yourself that you knew it all along. If the curriculum designers just let the simulation end here, every single 12-year-old would claim they totally knew there were 3 layers the whole time. But the designers built in a brilliant pedagogical countermove to trap them before they can rewrite their own history. Halfway through the excavation, on day 5, the students face a mandatory funding review. To get their budget for the rest of the week, they have to officially document their beliefs. They have to write down their current hypothesis, explicitly rate their confidence level on a scale of 1 to 10, list all their supporting evidence, and finally, sign it on the dotted line. And this brilliantly illustrates how the simulation pulls off its best trick. This day 5 record becomes the anti-revisionism record. When day 10 rolls around and the full 3-layer history is finally revealed, students can't just rewrite their own history. They can't say, "Oh, I knew it was a fishing camp," because the teacher simply hands them back their day 5 card where they literally wrote 10 out of 10 confidence this is a military fort. It acts as this undeniable metacognitive mirror, forcing them to confront exactly how wrong their anchored assumptions really were. But the traps aren't over yet. On day 8, students run straight into survivorship bias. In archaeology, survivorship bias means building an entire interpretation of a site based only on the evidence you actively found, while treating all the unexcavated areas as if they are just empty. You just naturally assume that whatever squares you haven't dug up yet simply must not hold anything important. Because hey, if it was important, you would have found it by now, right? Well, by day 8, a staggering 40% of the site's grid is still completely unexcavated. Almost half the site is totally unknown territory. The simulation suddenly forces students into this grueling gap analysis. They have to actually look at the blank squares on their map and explicitly state what they do not know. It forces them to realize that their super confident theories are actually built on massive, gaping blind spots. So by day 10, it's time for the final grade. So the crucial point is that success in this simulation isn't about who got the right answer. The grading rubric actually rewards honest reflection on being wrong. A student who completely missed the fishing camp layer but writes a brilliant essay identifying how anchoring bias and availability bias tricked them into chasing shiny metal, that student will score way higher than someone who just stumbled onto the fish bones but can't explain their reasoning. They must revalue the boring evidence and clearly articulate their own cognitive traps. Which brings us to the core philosophy of the entire chalk and ledger patience framework. Friction is the teacher. The designers didn't want a smooth, easy lesson. They intentionally rigged the site so that the students' own brains would constantly fight against the data. The frustration, the contradiction, the sheer embarrassment of reading your own overconfident day 5 journal, that friction is where the deepest learning actually happens. The biases aren't just vocabulary words to memorize, they are the literal obstacle course the students have to survive. Which leaves us with this final, really vital question for our own daily lives. Do you build your answers piece by boring piece, or do you just grab the loudest, most exciting one and call it a day? Every single time we read a news headline, evaluate a new project at work, or judge a complex situation, we are essentially standing right on the surface of Site 14. We can blindly follow the shiny metal and anchor on our first assumptions, or we can do the slow, methodical work of digging for the boring truth. The choice is yours. Thanks so much for joining me on this explainer, and hey, keep digging.